Thank you very much for inviting me. This is my first chance of being in Eskilstuna. I love broadening my horizons. So hopefully I can broaden your horizons a little bit about what I'm working on. And what I'm working on is this, the big picture. I'm a computational neuroscientist who ended up in the philosophy department of Oxford University because I couldn't keep to my topic. My advisor got many grey hairs for me not doing anything about brains or memory, but running off and studying a little bit about neural implants, and well, that's all right. A little bit about ethics, no, that doesn't sound very useful, and then writing papers about the future. And then I ended up in the philosophy department, so this is how it can go badly. And what I'm doing in the philosophy department of Oxford is working at the Future of Humanity Institute, and we got this lovely remit. We're supposed to look at the big picture, the long-range future of humanity. Not just the next 10 years, but questions about, well, where will we be in the next 100, or 1,000, or million, or actually trillion years? I'm actually working on a paper about that. It turns out that the expansion of the universe does have some nasty economic and ethical implications. But also, there are interesting questions about the threats and possibilities. What can we do with them? And how can we understand them better? So a lot of our research is about applied rationality, figuring out what's going on here. And this is where philosophers turn out to be surprisingly useful, because they get into these areas where there are no rules and try to figure out how to actually think carefully about it. After a few hundred years of mistakes and rather embarrassing papers, eventually somebody gets their act together, and it moves out and becomes its own department with nice funding, and everybody says, yeah, what has philosophy ever achieved? Look at economics, natural science, history, psychology. Yeah, economics and all those ones are useful. Philosophy part never seems to do anything. Well, hopefully we're doing something here. So I'm going to be talking to you a little bit about a first question. Well, what is the purpose of technology? And it's pretty obvious actually what it is. Magic. That is actually what we want to do. And here is a quote from a bona fide ceremonial magician, the slightly famous Aleister Crowley. This is his definition of magic. The science and art of causing change in conformance with will. And when we think about what we want our technology to do, is to get us what we want. Ideally, of course, in a very easy and convenient way, but the typical view in fairy tales of magic is that if you wish for something, and wish in the right way, even usually with fairy godmothers or wishing wells or something like that, you will get it. That is really what we want our technology to be like. We don't want just loose wishes to immediately turn real. That's kind of bad design. And we don't want it to be too hard. And we might even want to put in some limitations on them. But we certainly want to get this system working and actually create a fairy tale world. We actually want to create something a lot like our stories. And this is, of course, the enchanted forest we have achieved. And this is actually a very strange place. If we went back sufficiently far into history and asked our ancestors what they wished for, we'd say, oh yes, I want a world where I don't have to do backbreaking work all day to stay alive, and food should be really easy to available. Ideally, food with lots of fat and sugar and salt. That's yummy, that's yummy. And I don't want to get sick, and I want to live to a really ripe old age. And I think we have achieved that to some degree quite well. We might also notice that we might be should be a bit careful about what we wish for. Sometimes we do get it and realize, there are some problems here. Again, of course, the fairy tales point this out, and then usually get to the more about things should stay the same because that's the right thing. I think we can demonstrate actually that no, some things should change. And actually they are changing at an enormous rate. So we're living in the Anthropocene. Some of you might know about these geological ages, and there is an idea that we have left the Holocene and entered a new geological era, because the dominant geological force on Earth is no longer the normal form of erosion and activity of the biosphere, but actually humans. We are actually in I think the major factor causing erosion of rock right now. Humanity is fixating 190 million tons of nitrogen every year, which is about as much as the rest of the biosphere together. We're changing the geology of the planet on an enormous rate. Sometimes, of course, not for the better. But quite a lot of it is to our benefit. We're the most common large mammal on the planet, and we can be found everywhere. Actually, the total human biomass is simply staggering. We're outweighing most other big mammals, except, of course, for our domestic animals. In fact, we're creating a kind of domesticated world. Today, only 10% of the non-frozen land area of Earth is more than 48 hours away from the nearest big city. It's actually not that much wilderness left. And that means that we need to think about how we care about our planet, of course. And I could launch into the standard spiel here about climate change, etc. But, well, I'm rather optimistic. I'm more interested in how can we learn to be better at this? And where does robots come into this? Well, obviously, we want that change to happen according to our intentions. But our intentions are very muddled, and we're not always around to do these intentions. So sometimes we need somebody else or something else to do what we want. We also spread widely around. There might also be that we like to have company. There is a reason why so many robots are interesting and cute, because we also are very good at thinking socially. A lot of our brain is actually dealing with the kind of ongoing soap opera of human relationships. And that is important because we use that to understand physics too. We understand a lot of the world in social terms. So by actually adding a little bit of autonomy to our devices, we might make them easier to manage. And of course, we create the talking animals for that enchanted forest. Okay, what are the trends that are affecting us right now? Well, here is a bunch. I'm going to jump past them relatively quickly, because most of them, of course, are fairly well known. Generally, we are having a bigger population. We're getting fewer kids, so we're aging rather quickly. Most people live in cities. They might range from very nice ones to the rather nasty ones. We're actually getting richer, and even the poorest ones. It's just that, of course, we might be discussing the differences here. The world is definitely getting very globalized. It's not just that we're running out of resources, we're also reusing and reinventing what we're using resource for. So suddenly rare earths are a big political issue, and people realize that, copper, well, that's nice, but fiber optics is better. And we need to deal with that we have inadvertently created links between our social systems and our technological system and the climate systems in ways we don't really intend it. Oops. But it happens all the time. Similarly, society is changing in a lot of interesting ways. Of course, it's also popular to be scared these days, so we might worry about our security. We need much more education, and well, that's a problem, because if we're getting educated well enough, we're too old to work eventually. And all this change, all this globalization, all these links forces us to renegotiate a lot of our ideas. What about surveillance and privacy? The old norms have to be changing because we have got cell phones and cameras everywhere. I have a surveillance camera every 18 meters between my home and my office in Oxford. And it's coming to Sweden too. Even though it might not be the official cameras, it might be people's cell phone cameras. And then of course we have a democratization, people actually demanding much more control over their lives. But most importantly, of course, at least for this audience, is that technology is doing an awful lot of fun stuff. We're having a lot of technologies, not just computers, but that are accelerating. Not all of them fast enough. Japanese beer is getting exponentially cheaper, but at a fairly slow rate, which is maybe a bit sad if you happen to like Sapporo beer. We're getting enormous amounts of data that we can manipulate. We're getting smart into practically everything. There are wireless connections in more and more things, and as we get cheap plastic electronics and low power electronics, it's getting more and more sensible to add it to anything, which of course means that they can do surveillance. And as I'm going to return to, a lot of them are actually going to be robot ready. There are actually already sensors and actuators that you could use for robotic applications. And we like to automate things because it makes things cheaper and more efficiently, and humans are actually quite expensive. And we want to adjust it. Okay, where does that lead us? Let me give you a few examples here and look at the health, obviously. When we're needing a lot more health because we're getting older and people are going to be having various chronic diseases for a long time. It's also getting more expensive. People have proposed, for example, telemedicine, where you can use lab on a chip to make tests that previously would have required a trip to the hospital lab in order to do it in the home. In the long run, we might be seeing that people get various robotic automation to help them in the home, like we saw in that early video. But right now, it's probably mostly communication. But it's actually important to try to automate medicine as much as possible. So speaking as somebody in the philosophy department, I would say we have a moral obligation to make more medical robots. It's not just that it would be good business. It's actually something we ought to be doing quite strongly. Why? It's not just because it's expensive to healthcare costs. It's also very important in order to distribute it to the poor people. Typically, gadgets tend to come down exponentially in price over time. We learn how to produce them cheaply and we develop better tools for it. Services tend to remain at the same price because you need to pay that doctor, that nurse, those people who are actually running the hospital. Okay, so how can we fix that? Well, what if we turn medicine into a gadget? Of course, it's pretty hard to do everything in medicine as a gadget. We can't really all go around with these Da Vinci surgical robots at our home, mostly because we don't need surgery all the time, fortunately. Of course, if it was sufficiently good, maybe we would be using surgery all the time because it would be so fun. But everything we could automate in medicine and turn into gadgets would actually be morally a good thing because now we could distribute it eventually and across the world much more efficiently. This is, of course, an interesting example also that something that's morally good and economically good might still be very hard to implement because we're going to be a lot of doctors, patients and politicians who have very strong views on how medicine is done. And our medical systems are integrated social organizations which are very resilient to any change. Any young doctor can tell you that there are plenty of nice tools that are just lying around because the older doctors don't use them and look slightly down on the young doctors who use them. So we might want to figure out ways around that. Or maybe it's in the emerging markets that the real revolution is going to happen because we haven't been stuck with this kind of old social systems. So maybe the robo-nurses are going to be the Chinese robo-nurses, not the Japanese, because the Japanese hospital have had too long time to become set in their ways about what a robot nurse should be. Meanwhile, the real future might be happening when you get the robot nurse hackers down somewhere in Sichuan coming up with a really cheap robot nurse. Another interesting area is telepresence. Okay, climate is changing, we should all feel very bad for going on the long airline flights, but we're also getting globalized and we want to meet each other. We have our social needs and Skype conversations don't really cut it in many situations. Sometimes you actually want to act. So people have been starting to look beyond the normal video conference. Maybe we should put our head on a Segway and use that to kind of move around the offices somewhere abroad. It's obviously fairly primitive. But I think given that there is a very fundamental social need and a very important dilemma here about travel, I think telepresence might be something that's going to come quite a lot in the future. If it does, and again it depends on whether you can convince people that coming as a telepresence device rather than in person is the right social thing, and this has a lot to do with marketing rather than engineering. In that case, I think we're going to end up with a lot of these ones, which are essentially robots. So when I'm not using the telepresence rig, why not use it as a robot? Or vice versa. In a world where there's plenty of robots around, we already have telepresence equipment. And a lot of these systems are going to be linked together with the normal devices. This one is, after all, mainly laptops and standard equipment. What if we could use our cell phones and plug them in somewhere and use that for telepresence? All right, and then of course we have the smart cars. Again, this is probably going to be one of the amazing success stories of robotics. Is the DARPA Grand Challenge has been doing the rounds. Google is lobbying in Nevada, I think, to change the rules for unmanned vehicles. And again, the problem is no longer really technical. It's legal and social. Do we trust cars that have no drivers? Especially, do we trust them on the roads when the little old ladies are also drivers? And the traffic lights break down. One interesting problem, for example, with traffic lights is that a car is supposed to obey them. But there are plenty of red lights around on the road, from other cars, from stores, and sometimes traffic lights appear in unexpected places. Or they're broken. So what is the smart car supposed to do? Maybe we could mandate that all traffic lights should be sending out a Wi-Fi signal about their state. Or maybe we should say, yeah, let's have a very detailed map and load that into where all the traffic lights are. So the car can figure out where to look for a red spot. Or we should say, oh, let's make it really, really smart. My argument would be that all these are nice, but they don't really work always. If you combine them, of course, you get something more robust. And that is really the problem that we need to deal with. Something that works in this human-created world needs to be robust. It needs to be able to handle surprises, and it also needs to be transparent enough or trustworthy enough that humans can handle it. And it also needs to fail gracefully. We don't want cars to not fail gracefully when we get confused. It might be one thing if a computer during a presentation fails, okay, but on the other hand, cars, no, a little bit too dangerous. And this is really what's probably going to be the main hindrance for making smart cars, actually making them trustworthy. Generally, we kind of come up with all sorts of weird ideas from our toys. So these are quadcopter and bots. So over here is from the GRASP lab at University of Pennsylvania, I think, where we are doing some amazing aerial acrobatics using swarm algorithms, etc. And they have been used to build stuff. You can test out using them for surveillance. And of course, this is kind of mini version of the military drones, where you have a lot of money going into something that is going to lead to a lot of civilian applications. But this kind of devices, of course, come from the toy industry, really. Thanks to the gadgets we developed, which have low power electronics and better batteries, to accelerometers, etc., it has become possible to build fairly cheap toys that you control from your smartphone. And it's of course fairly easy for amateurs to add a little camera, and suddenly they have a drone. And suddenly, by adding your little standard camera to the toy you bought, you have something that is against the ITAR agreement about the fusion of technology, and at least according to American laws, that's a very serious military hardware. And this one is actually the Occupy bot. There is parts of the Occupy movement now who are developing, indeed, surveillance drones in order to check on the police. Very interesting because they have multiple controls. Several people are controlling them. So if the police nabs one of them, the drone will still be transmitting live on the internet and will not go out of control. So here we see another area. Robotics has traditionally been a kind of high threshold, expensive activity. But we're now getting to the world where you also have inexpensive robots that you can play around with, where you can open source things, where people can share experiences and ideas online. This is going to put a pressure from the below on the robotics industry, of course. If you're not good enough, then you can be replaced by something you get for free from the open source community or fab at home. And it also is going to produce a lot of interesting ideas. Many industries have realized that customers are, of course, the best designers and researchers they could possibly get. So that's going to lead to a lot of changes. Of course, one interesting problem to conclude with is the problem of autonomy. Well, things misbehave or go wrong. And how much smarts do we want to have? It actually turns out to be a rather subtle question. A normal tool like a fork or a knife is directly under my control. If something goes bad, it's because of me. And then of course we can add a little bit of autonomy, so it does something on its own. And suddenly it's much less safe, because now it might do doing something unexpected. As we build smarter and smarter tools, they generally tend to become safer. We can build in safety in systems. The really interesting things which we're doing research on and we can't really talk about here right now, but come to our conference in December about it, is we question what happens when you reach really high levels of intelligence. There are some reasons why you might be very scared about very smart systems. The real problem is that stupid systems, they misbehave because we cannot explain our intentions to them. Smarter systems misbehave because, well, partially we misunderstand each other. We don't get what the car wants, the car doesn't understand our traffic light. The really smart ones have different motivations. So we want to design things to have different levels of intelligence for different purposes, because we want to optimize things. So, leading to my conclusions here. Generally, it seems that the world is becoming robot-enabled, partially because we're living in the Anthropocene. But that's also a heck of a problem for the poor robots, because they need to understand us. And we're complicated, weird creatures who have a very complicated social understanding. We tend to assume that everything that is playing a part in our social world understands all the weird rules. And then, of course, the problem is that we also setting our priorities maybe a bit wrong. There are a lot of important things we're not focusing well enough. But we're getting it so cheap now to actually do this. So in general, creating robust robots that are just smart enough, an ecosystem, that's going to give us the talking animals for Enchanted Forest and hopefully some genies for our wishes, and is hopefully going to make the Anthropocene a really nice period to live in. Thank you.
Listening to you is like drinking from a fire hose. But the following speaker has not only been a thought leader when it comes to academia, he's also founded and funded companies within the realm of robotics. So a successful pioneer, if you will. So to take us a step further into how to cultivate and commercialize robotics, I give you Professor Rodney Brooks. Warm round of hands.
Thank you for that kind introduction. Magnus gave me a copy of his book right before this, and I opened it up, and the first thing I saw, it says, "We cannot entrust our understanding of the world to self-proclaimed experts."
No.
I'm not sure why I'm here. Can I have the...
yes, you will have the clicker, and I will dial up your presentation.
Okay.
And
So, you know, we're talking about, I spent a day yesterday at Robotdalen and was fascinated by everything that's going on here, and it's great. And a lot of you are academics and interested in robotics and how to get your ideas out into the world, and that's what I'm going to talk about today. Some of the demands for your ideas, because it is from, as you mentioned, people who don't know what can't be done yet are the ones who come up with the really bright ideas and drive forward our life in the, what was it, the Anthropocene? The Anthropocene. So I'm going to give some sort of thoughts about how to get from academic stuff out into the world. And you know, I've been around a lot of business school types, so this is a 2x2 chart here. And if we look at turnkey versus demo level systems on the left and limited cost versus unlimited cost, this is sort of where things sit. You know, unlimited cost and turnkey are military systems. They can be fantastically expensive. Demo level, limited cost for education, etc. And academics tend to work down in this bottom right-hand corner. But the money people who are going to actually fund stuff tend to like to be up in that top left-hand corner. So they're sort of in different places, and I'm going to talk about how to get from one to the other today. Why does it make sense to have robot companies today? Obviously, Robotdalen is all about this, but why does it make sense? And there's a bunch of reasons. One is customer pull. There's just a lot of jobs we don't want to do. As you said, we don't want to do back-breaking work. People don't like that. For rehabilitation and deficit assisting people, demographics is a really big driver. I'll come back to that. It's turning upside down the elder to younger ratio, and that has a lot of implications. More productive and competing globally, and in some countries, hostility to immigrants who have often done the dirty, dull jobs that the locals don't want to do, but there's a lot of pushback against that. At the same time, there's technology push, and Moore's law has been very, very good to robotics in terms of sensors and actuators. And we can now start to replace some mechanical precision with computation. So even though mechanical things don't get exponentially cheaper, we can use cheaper mechanical stuff because computation can compensate. And within artificial intelligence and computation, there have been a bunch of trends which have given us more capable robots. And people are starting to worry about user interfaces and how ordinary people can deal with the robots, which is important. So in the last decade, we've had an incredible uptake of robots in ordinary life. And we already saw the Da Vinci system in the top left corner. We've seen lots of home robots, and then lots of military robots out in the world. And I'll just tell you one story. This is from a lot of robots have been in Iraq and Afghanistan dealing with roadside bombs. In 2002, the doctrine in the US military was to get the youngest kid in the squad, put them in a bomb suit, and send them out with a rope tied around them to pull them back to poke the bomb with a stick. And now the doctrine is you have to send a robot. Here's a robot that got blown up in Iraq, and on the back of its head is what the guy who was the operator had been keeping track. Had been one vehicle-based improvised device, 17 improvised explosive devices, and one unexploded ordnance, and then the robot got blown up. He brought him into a depot and said, "This is my robot Scooby. Can you fix it?" And they said, "No, but we can give you another robot." "Oh, no, I want Scooby fixed. We've been through a lot together." It's been interesting to see the connection between people and robots that one wouldn't necessarily expect. So since 2002, the number of ground robots in the US military has gone from 0 to more than 12,000. And the number of home cleaning robots in the US has gone from 0 to more than 7 million in people's homes. That's a pretty big uptake, a pretty big change in the last decade. I've been involved with a bunch of these through one of my companies, iRobot Corporation, that does a lot of home robots, does a lot of military robots, and the military robots also have other uses. The one in the middle there is actually an underwater robot which can go for about 6 months, and when the BP oil disaster struck in the Gulf of Mexico, we had our robots out there going underwater and mapping out where the oil bloom was, which was not available any other way. And in 2011, in March, when the earthquake hit Japan and the Fukushima power plant had its meltdown, a few days later the Japanese government called us up and said, can you send some robots? And we immediately sent robots, 2 different size robots, 2 different classes of robots, multiple of each. Some of them went inside the reactor buildings, and you think of a nuclear power plant as high-tech. Well, it's a 40-year-old high-tech nuclear power plant, so the instrumentation was not digitally connected, and the robots had to go into very high radiation areas and look at analog dials and send that back video, and then have multiple robots as Wi-Fi hop stations along the way. And then the larger robots are going in and actually doing some of the physical cleanup in there. My message is that the world needs robots, and the world needs robots for a bunch of reasons, but primarily I think the overall driver is demographics, and this is Europe in 1950 with a histogram of age distribution of men on the left, women on the right. That's 1950, that's 2000, and that's 2050. And the ratio of older to younger people is changing drastically. It's even worse in Japan. There's 1950, 2005, and 2050. It's even more pronounced there. You may notice up in the top right, the number of 90-year-old women. There's more of them than 80-year-old or 85-year-old women. That's because it's 95 and 100-year-old women joined together. It turns out, if you want to live a long time, it's best to be born a Japanese woman. And it's even better to be born a Japanese woman in Okinawa. I missed my chance, so I'm probably going to die younger. But what does this changing ratio mean? And here's data in a slightly different form for the US, where the percentage of population above 65 is about to skyrocket. It means there's less people to provide services to the older people. We get worried, at least in the US, about whether there's enough younger people paying taxes to finance the retirement of the older people. But then it's sort of double whammy, because those older people are competing for services from less younger people, so the price of the services go up. And I believe that here in Sweden, it was just announced you're all working till age 75 as a result. So that the productivity of the younger people has to improve, and I think that's really going to drive robotics in all sorts of industries, not just elder care, which Robotdalen is one of the focuses they have. So there are new robots around. Here's a few robots from my lab over the last few years at MIT, with humanoid form, doing interesting things. But these new robot capabilities that are in the research environment are going to change what we can do, allow ordinary people to directly control robots, which we didn't used to allow. It's like, it was mentioned at the start, it's like it's 1973 and we're looking at the PC. The PC was a democratizing thing. Before that, computation had been in mainframes and ordinary people didn't get to touch it. Over the last 10 years, we've been putting robots in people's homes, and now ordinary people start to touch them, and, by the way, they start to hack them and change what they can do. And that's what happened with PCs. Ordinary people got to touch them, hack them, use them in new ways. It's going to change the nature of robots and how they're used, and it's going to produce new killer apps. Now, this is probably a bad word to use with robots, given. In fact, Tan Lee, she's an Australian woman who has a startup out in California. She refers to them as manslaughter apps, because they're the unintentional ones, are the ones that really change the world. But one of the new, we can't quite imagine how robots are going to be used. We couldn't have imagined in 1973 that we'd all be carrying around devices in our hand which had the world's knowledge immediately available to us. We just, no one would have believed that. And if you look at Star Trek from the time, you see how far off that is from what the people were thinking was possible in the future. So it's going to change our world completely. So let's all invest in robots. Let's go build new robot companies. Good. But there's a little problem, and that's it's tricky to be a robotics investor. It's very tricky for I think 3 reasons. One is, unlike in some other areas, it's really hard for an outsider or even an insider to tell what is hard and what is easy to get a robot to do. It's really hard to make that judgment. And it's difficult to predict whether the market's going to be responsive to a radically new solution. That's another problem. And thirdly, normal conventional top-down engineering doesn't work very well on robots because robots are such complex interactive devices. And I'm going to explain these 3 things. So what's hard and what's easy? Well, science fiction robots are fantastic. So often when I talk to a reporter, they ask me, why doesn't your robot do X, Y, Z? Because they saw it in a science fiction movie, it must be easy. Well, it's not necessarily. And I also think, unfortunately, a lot of Japanese companies have had fantastic robots in the fantasy sense, where their videos of what they do are not real in the sense of what the robot would do if it was in this room now with you and me going up and interacting with it. The movies are rather staged. So that has given us a full sense of what's hard and what's easy. And often lab demos that you great academics do are done with underlying assumptions that you may not even be aware of. You're not trying to fool the world, but you may be fooling yourself in how well it really works because you're the one who's nursing along the demonstration. And so researchers are unaware of these underlying assumptions themselves. So transferring that to a real application out in the world may be hard. Now perception is effortless for people, but it turns out to be very hard computationally. I'm going to give you an example of that in a minute. And it's largely unsolved for robots, I claim. Our perception system for our robots are really not very good at the moment. So why is perception so hard? Well, I just want to say, and people said, but the connector's coming along, you've got 3D data, that's going to make everything easy. Well, the 3D data is just 3D data, you still have to computationally do something with it, it's still hard. So here's okay, Anders, can I ask you what that's a picture of?
It's a chessboard with a green cylinder.
Yeah, and how do you know it's a chessboard?
Well, it's just a chessboard shape that we don't count with squares.
Well, not the wrong number. Yeah. So, but why do you say what makes it chessboardy like?
Squares of an alternating bright and dark.
Yeah, alternating. Yeah, they're squares and they're alternating. They're actually not squares in the picture, but you corrected for that in your head somehow.
It's isolated.
But yeah, like that one is the bottom one is white, the top one is dark, right?
Yeah, it seems so to me.
Yeah. But they're really the same because if we start sort of covering stuff up, they're exactly the same color. But why did they look? Why did they look different? Well, there's a shadow being cast by that cylinder, and our brains are compensating for the shadow and compensating for the local brightness. So even though what's reaching our eye is exactly the same brightness, we're doing the right thing. You did the right thing. But computation, that's very difficult. Sensing and perception is still very difficult for our computers because it's so effortless for us. We're so good at it. We don't realize how hard it is. So that's the first thing. What is easy and what is hard? Business models. iRobot Corporation, a company I founded in 1990, reported its financial results last night. It did $465 million in business last year, which is nice. But I started with 2 undergraduate students in 1990, and we didn't have a clue what we were doing. And we went through 14 failed business models before we got to one that worked. And some of them were a little strange, like sending robots to other planets. But number 6 there seemed like a good one, sell nuclear power plant inspecting robots. And we tried really hard with the Japanese during the 90s to sell nuclear power plant inspecting robots. They didn't want any until they had an accident. Then they called us up and said, please send them now, which was in March. So you can have business models which may seem wacky or may actually be good business models, but convincing the world that they need them is maybe difficult. And so timing and luck is almost everything. The third thing that I mentioned is that robotic engineering is different from ordinary engineering. So if you gave me a jet airplane with just a manual control system on it and gave me $5 million, I'm sure I could robotize that airplane and make it be able to fly from Boston to Los Angeles without a person involved. I'm confident of that. We know how to engineer that sort of thing. Sounds like a complicated thing to do, but the plane only operates in a few distinct phases of takeoff, cruise, and landing, and the control equations for what goes on during that are well understood, and we can do it. That I can do, $5 million, no problem. I had plenty of money left over. Here's something, you can give me $50 million today. Give me $50 million today, I'm not sure I could get a robot to do the following thing. You ready for this? I don't think I can get a robot to do that for $50 million. Well, certainly don't want a robot putting its hand in my pocket. Look, getting a robot, put a hand in a pocket, pick up a flexible object, there's other stuff in the pocket, I had to distinguish between that tactily, I had to move my fingers around, and I had to pull it out and manipulate this floppy thing in the real world. Unlike the airplane example, where the boundary conditions of the control law are stable for minutes at a time, here the boundary conditions are changing every few milliseconds as you do something. And you have to change the control laws, you have to select them, and you don't really know much about, you don't have very accurate models of what's going on or very accurate information. It's a much harder problem. Robotic systems are inherently harder to build because they're dealing with complex, changing environments continuously that other sorts of engineering doesn't have to deal with. So, engineering robotic systems is different, and that makes it hard to guess whether someone's idea that they come to you with, look, I can do this in the lab prototype, whether that can really turn into a robust system that a company could live off and sell is hard to tell. So there's opportunities and barriers. But I think it's worth going after them. So suppose you're an academic, and I know there's a bunch of academics here, and you've got this great idea. How do you get it out into the world? Well, how do you have impact? Here's some strategies for getting your ideas out of the real world. One is to hope. Hope someone uses this. And then you get grumpy and complain when it isn't happening. I designed the best fuse at Watson, and no one's using it. Now another way you can do it is to go and register your idea with your institutional licensing office. And that's sort of the same as hope, you know, I mean, not much different. You can have a commercial sponsor, and this is part of one of the ideas around Robotdalen. It's a good idea, but you have to involve people. You can't just have the lab and the sponsor separate. The people have to go back and forth between them. Otherwise, the idea never actually has any impact. And you don't maybe don't get the financial reward nor the headache of starting a company that you would. You can consult for companies, or you can start a company around your idea. And ultimately, I think, if you really start a company around your idea, it's hard to stay in academia. At least you have to leave for a few years to do the concentration to get it out into a product that you need to do. So you've got this idea, it's your PhD thesis, it's a great idea. Well, that's not the whole story. The great idea is just a little part. There's really it's really only 10% of what you need. You need another 90% to turn it into something real. And now you've got something that you can go and raise funding on. And then you get the funding, and then you do the other 90% on top of that that turns it into a real world product. Now you got the real world product. You got to do another 90% of sales and marketing. And I always see engineers, why do we need those marketing people? They don't add anything valued. Well, yeah, you'll still be living in hope land unless you have that. So, for instance, the Roomba vacuum cleaner, it was 10 years between our first lab prototype at MIT and our first sale. And then it was another 8 years of refinement until we got to what we think is sort of the stable product. So 18 years of work to get it out there. But it's selling $1 million a year now, so $1 million a year. Lastly, I just want to wrap up and say academia is different from industry because there are different reward systems. And you know, I'm going to put them up left to right. You know, elegance and novelty of ideas is important in academia, but what's important in the commercial world is some customer wants to pay for it. They don't care whether it's elegant. You're rewarded for having lots and lots of ideas in academia. That's maybe not so good when you're trying to build a new system and deliver it, and so on. In academia, the ideas only need to interface to a conference paper. But in the real world, they need to interface to the rest of the product. And in academia, the idea doesn't really truly have to be practical. It just has to sound clever. But it has to be cheap and reliable in the real world. The artifacts are very different. You know, if you have seen a demonstration in academia, there's a team of PhD students whose careers, you know, revolve around the demo working. But when you send it out into the real world, you have an owner who thinks they paid too much for it, and they just want it to work. They just want the magic of it. This was in the last talk. And lastly, I just want to say this, I've experienced this from both sides. An academic working with a company gets frustrated with the industry engineer, and the CEO of a company gets frustrated with the academic. You know, as an academic, I found engineers in industry wouldn't read scientific papers. They just, you know, I'd give it to them, and a week later they wouldn't have looked at it. Whereas the CEO looks at the academic and thinks the academic has contempt for customers. They don't really care about them. Now, an academic, you know, has certain intellectual theories and debates. The engineers don't care about them. And the CEO looks at the academic and sees that they care way too much about their pet technique rather than satisfying the customer. The CEO thinks academics are unwilling to compromise, even when the alternative is to shut down the project. No, the right way to do it is this. And that's a big struggle. And lastly, an engineer wants specs that they can engineer to, and the academic is saying, well, we can't really nail down the specs on this. It's more complex than that. You don't understand, but you really need to get to the specs finally. So there's a lot of room for new companies, and I hope that all of you go out there and build new companies and make the Robotdalen the great crucible for many, many new ideas. Thank you for your attention.
Thank you for brilliantly capturing the Twitter feeds from conferences like this, where engineers are like, why didn't he get into the intricacies of AI and how it hasn't developed the way we thought? And the business people says there's no business in this. So that was beautiful. Thank you. Who has an idea that they are cultivating or is about to cultivate? Who's starting a company, running a company in robotics? 3 people, 4, 5, 6, right. Who's thinking of maybe perhaps one day starting a company within this realm? All right, who is like deathly afraid of ever going rogue, as you will, and setting out your own sales and starting your own company? Who hates putting their hands up at conferences? It's okay, it's okay. I sort of expected that when you have Minecraft t-shirts in the audience. Yeah, but it's all right, you have smartphones and Twitter, that's fine. You will find out sooner or later that money is important. It matters, and so on. It enables you to be patient. Somebody once said that money is one thing, it's frozen freedom, right? When you need a little bit of freedom, you want to take Friday afternoon off, you take a bit of money out of the refrigerator, boom, you're free, at least for the afternoon. So to take us into money and funding and venture capital and all of this, we have a professor from Stockholm School of Economics. And you know, bear in mind that about 12 years ago, there was another revolution that sort of fizzled out because of the wrong funding method, the dot-com boom. So to make sure that we don't make the same mistakes, I give you Professor Per Strömberg from Stockholm School of Economics. A round of applause. And let me dial up your presentation.
Oh, okay, excellent.
Yeah.
Can I put my...
Yes, that's your glass of water.
There's a slight risk that the whole conference will be ruined.
No, that's fine. Okay. You know, we have robots to deal with this thing.
Okay.
So that's fine.
So it's a bit humbling to be here because you know, I'm a simple-minded, boring economist. I'm not a visionary. I don't know anything about robotics. Okay, I should leave all right away. No, so I guess my job here is to talk a little bit about the world of funding startups, and at least there were a few people who had these types of plans. And obviously, if you want to start a company, you need to find someone else typically to fund, because you don't have the money yourself to build your company on your own. Now, at the outset, okay, so again, I not feel bad, you talk about there are too many pessimists around. Okay, let me just start with finding money to start new companies is unfortunately extremely hard. And the more interesting the company is, the harder it is, okay? So to find a bank to lend you money to start a new dry cleaner is much easier than to find, money for a new robotics company that will change the world, okay? And, if you think about it as an economist, why is it so hard? Well, I think the sad fact is that most ideas are really not good companies. I guess you went through 14 of them before you came up with the ones that work, okay? That doesn't stop people from trying to fund them. That's the sad truth, okay? So this may be because, you're really optimistic about things, you don't quite understand your idea, and there's also an aspect of what we as economists call, moral hazard type problems, i.e., who wouldn't want to start a company if someone else paid for it, right? I mean, if the money is lost, well, it wasn't my money in the first place, okay? So that means that there are going to be too many projects that wants to get financed, and financiers are obviously very worried about this, which means that they're going to be extremely, extremely, extremely careful to give money to someone to start a company. As a result, sadly, okay, the few golden nuggets we have, the few good companies, the few good ideas we have out there that really should get funding, many of those will unfortunately have a very hard time getting it, okay? Because they're sort of mixed into this pool of ideas that really are going to have a very hard time taking off. That's actually a huge problem, not only for robotics researchers, but for society, okay? Because we really are very dependent on new companies, new innovative ideas for economic growth, okay? Now, to add some more misery, okay, these problems tend to be much harder when the economy is in a downturn. Well, maybe that sounds like sort of a tautology. Okay, if we have a recession, it's harder for everyone around. But it turns out it's especially hard for early stage companies, okay, to get funding, because investors become much, much more risk averse, okay? So first of all, maybe investors don't want to invest so much if there's a downturn, but the money they do invest, they tend to go for safer stuff, okay? And this is a bit of a paradox, because a lot of the research I've done in this field actually shows that the few investments that you actually dare do in economic downturns often turn out to be the best investments, okay? But, there's a way in which investors behave in a very risk-averse way in economic downturns. Just to show you, just a picture of this. This is just a picture which is meant to illustrate the amount of venture capital funding raised in the US over time, and it's normalized by the size of the stock market. And as you see, these things go in cycles, okay? And obviously, as was mentioned earlier, we had a dot-com boom a little bit more than 10 years ago. And at that point, by the way, it wasn't very hard to start a company, okay? I know several people, undergraduates, just leaving the Stockholm School of Economics. Oh, I want to make a web page where I sell condos in Spain. Oh, can we please invest? Here's $10 million. Okay, what's that kind of environment? Which obviously then backfired, and we got, the other, the downturn cycle. We had an upturn in the last few years, and now we're in the down again. Okay, so that's the environment we're facing right now in the world of early stage, or financing for venture capital type projects. Okay, so if you have an idea and you truly believe in it, and you want to start a new company, how should you go about finding your money? Well, maybe this is obvious, okay, but the cheapest money, okay, the best way to fund a new idea is funding it yourself. Okay? I mean, that's really, okay, starting, okay, like that. But, the thing is that whenever someone else is giving you money, okay, that person who's giving you money will have to start worrying about your incentives, your motives, and so on, okay? Which means that they're going to worry about, well, is this a guy or girl for real, okay? Do they just want to steal my money, or they want to pursue some pet project that I'm never going to make any money from? And when it's someone else's money, you have a much bigger incentive to do that. Which means that the best way to finance a really early stage idea is really scrambling, mortgaging your house, okay, getting whatever funds you can yourself to fund that venture. And this is also going to be very important because, not only because for the reasons I said, but even if you get in an early stage an external investor to actually give you money to pursue your project, it's going to be extremely expensive. Okay, the earlier it is, the more expensive it's going to be. They're going to ask for an arm and a leg, okay, because of all these uncertainties. Okay, so if you go too early, and then this company becomes, iRobot, okay, you may end up, oh, this was a fantastic company, it's worth $1 billion. Unfortunately, I own 0.01% of this company now, okay, because you went too early and you basically got too expensive funding, okay. So the best way, okay, and maybe a lot of people then are like this, okay, there's nothing in your pocket and you've mortgaged your house and you've sort of done whatever you can. Okay, so what's the next step? Okay, well then my advice is to go what I call benevolent funds. Okay, another way to think about this or name this is people who really don't care about making money. Okay, those are good people to go to in the beginning. There's in the venture capital world there's a famous term FFF, which stands for friends, family, and fools. Okay, so those are sort of good funding sources early on. Okay. Because they may, be willing to fund you even despite these uncertainties, because they get some kind of, emotional satisfaction of actually helping you. Okay. Then there's obviously the government. Okay, and there is government funds available. We're in Sweden, and probably most of you know about Allmän Innovationsfond and so on. So that kind of funding, I guess, is more suitable for these early stage projects. Banks, which would be the natural place to go if you want to start a grocery store or a dry cleaner, unfortunately are very hard, as you probably know, to fund very early stage things, because early stage ideas don't generate any cash flow, and if you don't have any cash flow, you can't pay interest, and you don't have any collateral, anything that the bank can take if you go bankrupt, which means that they're not going to give you money. Okay, let's say we've talked to all our rich uncles and aunts, and we've gotten as much money to push our company a little bit further, to develop the idea a little bit further, maybe with some research grants, maybe with some government subsidies. Okay, so now you realize, okay, I have to find a real investor here. Well, one important principle here is, as I mentioned, there's this big problem with external investors making money from startups, because it's so risky, there's so much uncertainty, there's so much sort of moral hazard problems, information problems, etc. Okay? You need an investor that can turn the odds in their favor a little bit, okay? That can actually make the odds better. And how can they do this? Well, they can actually, if you find an investor that can contribute with not just money, but something else, some skill, some knowledge, that can actually make your company better. Okay? That is a crucial thing to kind of turn the odds in the investor's favor and actually make them make it possible to make money from investing in your company. Okay, these could be people who know the industry well, people who have a lot of investors have a lot of contacts, potential suppliers or customers even, and so on. So these types of value-added investors, and I'm going to come back in a minute. And basically, venture capital is sort of an ultimate sort of value-added investor in this sense. At least they like to think about that themselves. So I think the last is a little equation here. There are a lot of engineers here, so it shouldn't be too hard. Which basically says, okay, when you think about getting an investor in your company, okay, what's sort of the rule that you should try to follow? Well, if you get an investor in your company, they're going to demand a big chunk of your company. That's X. Okay. So if I own 100% of my company now, when I get my investor in, maybe I own 50% of this company, okay? I just gave away half my company for this money, okay? Is it worth it? Well, you want to be in a situation where having 100 minus X% of your company with this investor involved, okay, makes the company worth more than owning it all on your own without this investor involved, okay? Now, to make this equation, to solve this equation, you typically need the value of the company with this investor engaged in your company to actually be worth more than if you didn't have this investor on board. That implies you want to find someone that can actually add other types of value than just money. Now, what is an example of these types of investors? A very important example is what we call business angels. And what are these business angels? Well, it's basically, in some sense, it's rich people, okay? But it's rich people that also know something about, you know, building companies, okay? Many business angels are former entrepreneurs that have, you know, built a company, made a lot of money, and now they want to help and support other angels. Even in Sweden, where we maybe don't see as many rich people around as in Silicon Valley, there are some rich people who do this kind of thing. Some of them are very visible and almost become like venture capital funds in themselves. Niklas Sandberg, everyone knows, okay, has a company called Atomico Investment, where he basically supports other startups, and ideally in things that he knows, okay? So he can add a lot of value to these startups as well as money. One of the limits with angel money, obviously, is that even rich people are not super rich, okay? They can't typically fund a very, you know, a capital-intensive industrial project from start to finish, okay? They don't have those kind of resources, or they don't want to put all their eggs in one basket. So it's kind of typically then angels are more suitable for early stage ventures before you have these massive capital needs. One thing that we've seen in this market is that angels often team together in sort of, there's a famous Silicon Valley one called Band of Angels, but basically lots of rich people go together, they sort of think about projects, try to find projects, and they pool their money into these things to be able to invest bigger amounts. Now, a big problem with angels, and they do exist even in Sweden, okay? But they typically don't like to put in ads in the paper. I'm a rich guy who wants money, you know, with Dagens Nyheter. Because then they tend to get the wrong people and so on, okay? So they're often kind of hard to find. They work through networks they have. Almi, which is a government agency supporting startups, they you know, have, I know that they keep sort of a register of people who are interested in finding investments and so on. But typically you need to use some kind of network to find these people. Okay. Now comes venture capital. Okay, venture capital, probably something at least most people in the world have heard the term. You may also have heard about some of these world famous stellar venture capital funds, Sequoia, Kleiner Perkins, Accel Ventures, who are big investors in Facebook currently. So what are venture capital funds? Well, I think venture capital funds are basically big institutionalized funds that have much more money, and they believe themselves to be the ultimate smart money, okay? Which is true. The top, at least for the top venture capital funds, you have truly extraordinary individuals like Mike Moritz at Sequoia, who's just like, you know, visionaries who build companies, can contribute huge amounts of value when you build companies, okay? Now, since these VC funds though have these very high-powered individuals who wants to build money, and they also, as I'm going to come to in a second, have a quite limited horizon when they want to see their money back. Okay? That means that there are just a very tiny fraction of early-stage new ventures that are actually suitable for VC financing. And if you do get VC financings, these types of funds are experts at taking value from you and taking control from you, okay? Because that's also part of their business model. Okay, so what is venture capital more from an economic sense? Well, in Sweden we talk about this thing called riskkapital, which is a bad word because in the US you would call this private equity, the private equity market. And there are funds in this market that invest in very early stage companies, that's what we call venture capital. There are other funds like Nordic Capital or EQT, okay, that actually have a kind of a similar structure. They also try to add value, but they invest in more mature companies. Now, why are these typically put under the same, under the same roof? Well, they're all financial intermediaries, as we call them. Okay, these VC funds, they don't invest their own money; they invest the money of big institutional investors. Okay, they get money from pension funds, insurance companies, maybe some rich individuals, and then these individuals, they make a commitment. Okay, I put money into your venture capital fund, but in 10 years, no later than 10 years, I want my money back. Okay? What this leads to is that the horizon of these VC investments, venture capital investments, is going to be by necessity reasonably short, okay? Because they need to give their money back to investors within the life of this fund. But they can do a lot for companies, and I don't have so much time here, but sort of a laundry list. I mean, there's lots of evidence that VCs do a lot to help companies. I think one of the most important things they do is actually professionalize the business, okay? Help you hire the right people, get the right processes, and so on. A lot of recruiting help is what these funds do. But introductions, feedback on strategy, etc., etc. Obviously finance. Now, they're going to be very picky, okay? Because not so many ventures will fit this business model. If you have 10 years, okay? So think about the objective is, okay, in 10 years I need to give my investors money back, okay? Maybe I find 2 years out in the life of this fund, I find a venture that I think is really interesting and I want to invest in. Well, that means I have 8 years left, okay? So the typical investment horizon for these venture capital funds would be something like 5 to 7 years if everything goes well. On top of that, even if you're a good venture capitalist, maybe only 1 out of 10 of your investments become like a real home run, or maybe 2 out of 10, okay? That also means that if you invest in a company, even if it's a good company, okay, it really has to have the potential of really moving the needle for your fund. Which means that if you have a fund that's $1 billion fund, well, this company should potentially, or $1 billion kroner fund, okay? This company should have the potential to become $1 billion kroner company, okay? And not all companies, good companies, have that potential. Okay? Now, there's ample evidence that the VC model works for improving companies. Where there's much weaker evidence is that currently, at least, is that the VC model works for actually making investors make money. Okay, so in recent years, sadly, even the good venture capital funds haven't returned so much money to these pension funds and institutional investors as you may have hoped. And this, there's too much numbers on these slides, but basically, the average venture capital fund has brought back 97% of the money to investors, okay, which is not the return they hoped for, obviously. This has meant that the VC market actually globally is in a bit of a crisis right now. The Swedish VC market has had a huge shakedown. Okay? We probably had 100 or more venture capital funds in the late 90s. Now we basically have 2 independent venture capital funds, Corandum and Northstone, that make investments. We have some other VC players that are really not funds, but they're subsidiaries of other companies. We have some semi-public actors and so on. But a lot of what's happened is that a lot of early stage investors have gone more interested in investing in later stage ventures rather than early stage ones. Many reasons for this. The bubble was very harmful to this industry because when you had the internet boom, lots of VC funds entered the market. Then you had the crash. All of these VC, very few of these VC funds that made any money because of the crash, and they left the market, and we're kind of still suffering. Investors' memories are still suffering from this period. There's an interesting dynamic here too, which comes back to the big trend of demographics. Okay, so with the elderly population we're having, not only do we have many old people, but we have lots of pension money around. Okay, so pension funds are actually becoming bigger and bigger. Okay. But if you're a big pension fund and you want to invest in venture capital, okay, these venture capital funds are not so big. Maybe maybe $1 billion kroner sounds big, but it's not such a big fund. Okay, the most you can invest as a pension fund is maybe 100 million kroner in this fund. If you have 20 billion to invest, okay, in private equity, you really don't have the time to sit and like invest 100 million chunks in lots and lots of funds. Okay? So the venture market is very squeezed at the moment, and because these pension funds are becoming so large and they're not sort of interested in investing in these types of funds anymore. There's another dynamic, and now I guess I'm seriously out of time because this thing is buzzing all the time. But academics are hard to control.
You have about 4 minutes.
Okay, excellent. Okay. The other dynamics here, which is also bad, is that these VC funds, as I said, they're not large, and they shouldn't be too large, because what we've seen historically is that venture capital funds that grow too big, that get too much money to invest, then they start contributing more money than skill. Okay? As I said, the trick here is to be smart money. You contribute, maybe money isn't the biggest thing you're contributing, it's skill. Okay? But when you get too much money, well, then you're starting to throw money at stuff, and you really don't have time to engage in the companies, which is really bad for your performance. Okay? So venture funds in these early stages, they shouldn't be so big. That poses another problem, though, because if you're a very high-powered individual, okay, you're a high-flying researcher, actually not so many researchers start venture funds, but say you know, high-flying partner at McKinsey or something like that, and you're making good living, high salary, okay? You really have no interest in raising, you know, $500 million kroner, or say even, you know, a couple of 100 million kroner, which sounds like a lot. But then you're going to live off a few, you know, 1% or 2% of this money every year, and you have to build an organization, you have to hire people, and so on and so forth. So these small funds are not very good deals for high-powered people. Okay, so there are not so many people interested in starting these early-stage funds. And then, as I said, the 10-year horizon, there are very few early-stage startups that you can actually build in 10 years. Okay, they took 18 years. Okay, which I think is typical for a lot of innovative projects. So what has happened is we have a very big dilemma now, not only in Sweden, but I would say internationally, in financing early-stage ventures. What has happened is that we now have, the venture funds we have in Sweden are actually quite successful. So both Trandum and Northzone, for example, are big investors in Spotify, which everyone predicts to be a home run investment, and they're going to make a lot of money. However, the type of early stage ventures they're looking for right now are ventures where they can see some signs of success, i.e. some cash flow pretty early, before they've invested too much money. So the favorite thing now is companies like Spotify, Facebook. Okay, you didn't need actually to invest so much in Facebook before you started seeing whether this thing works. What's definitely not in favor, unfortunately, with these funds is long-term industrial projects where it may take 5 years before you see whether your prototype works or whether anyone wants to buy this thing. Okay. So that is a problem. So what are you supposed to do as a you know, if that's the type of business you're in? Okay. Well, I think there are some alternatives that are interesting. So working with a company as a financier, I think, is an important model. Some of these companies obviously invest directly in projects. Okay. But what at least used to be a big trend about 10 years ago was that companies started their own venture capital funds. Ericsson Ventures, Nokia Ventures, Intel Ventures is one of these legendary corporate venture capital firms. The benefit here is that they can have a much longer time horizon, right? They can sit it out. They don't have to stick to this 10-year fund life. They can have a longer horizon. They also typically, if you're a strategic investor, have a lot of things to add to build these companies apart from money. There's a big, big caveat, though, that maybe there are some industrials in the room here and going to be angry with me. But the thing with industrials is that they typically don't have the same objectives as a typical investor. Okay? A typical investor wants this company to grow, become as valuable as possible, sell it, and then I make money. Okay? An industrial investor may have different strategic motives. This often can lead to conflict, okay, if you have people in there who actually want to make money. So what has turned out historically is that a lot of venture capital funds are actually quite hesitant to fund projects with a big strategic investor involved, because they don't want to have someone who cares about other things than just creating value. Then finally, government initiatives, I think, is something we have to work with, not least in Sweden, because it's going to be a very important piece to solve the early stage funding problem. The models, though, must say that many of these models haven't worked so well. Okay? I'm on the board, for full disclosure, of the 6th AP fund, which at times, or at least historically, has invested in startups themselves, doing miserably. Okay? So it's very hard to get this model to work with a government VC fund. I mean, I think the best way of the government to subsidize this industry historically has actually been the government being a customer of these companies. Okay, so I think the Silicon Valley success is largely thanks to the US government being extremely active, not as an investor, but as a buyer or a solicitor of products like NASA or the defense. That said, okay, there are some, not a huge amount of companies, but there are some notable successful industrial type companies, and I just listed them here that we've seen. So don't despair, okay? It can be done, but it's hard. So, you know, I don't have time to go through this list, but one of the things that when you look at these companies that is actually typical of the investors is there are not so many of these companies that have been funded by typical venture capital funds. A lot of them have actually been funded by corporate type VCs with longer horizons. And the other one, ClickTech, I don't know if you've heard about that. That was like a huge success. They do industrial software. Industrifonden was a big investor there. Very good investment in the end, but it took them 15 plus years, okay, to get their money back. And for these normal VC funds that were in there early on, they actually didn't make any money because they couldn't hold out for the whole period. Okay. But it can be done. But you know, there's a lot of work to do in policy and so on to come up with a good model for financing early stage venture. Thanks.
Thank you, Professor. I'm going to give you 3 chairs on which to sit. Actually, I'm just going to give you 2 and you have to fight it out. No, Rodney, you can bring that up. So, and before I start asking some questions, I'd like to open the floor or the seats up to ask. We have roving mics and you have loud voices. Bear in mind that people are on average 50% more pleased with the conference at which they themselves have been speaking. So, you know, oh yes, we have a question. Let me rush up with the roving mic. Here you go, say your name and who you're from and fire away.
Hi, my name is Leif Allman. And I wonder, do you think that the robot industry will be like the computer industry, that is military, and the sex industry who will prove to make it work?
Thank you, great question. Sex robots.
But if it can't be. Well, actually, any industry needs to go to a human need. And, well, there is a human need for defense, and sadly a tendency to do a bit of offense. And of course, humans do have sexual needs. If we think about the computer industry right now, the social needs have, well, at least parts of it met, and that's creating an enormous boom. So I think, yeah, if we take a look at what humans like to do, what humans want, that's probably where you will find the most profitable robot applications.
If I to put a boring economist perspective, I actually don't have so much to say about sex. We'll leave that to the philosophers. But about defense, one of the important things with innovation, okay, and that's why we care so much about this as economists, is that an innovation gives value to so many people apart from the ones who actually paid for it. Okay, so if you pay to build a fiber, okay, in Sweden, well, that benefits a lot of people. You know, there's a lot of value in that actually doesn't go to the person who paid for putting down this fiber. Actually, the people who built our internet infrastructure here, most of those companies failed miserably. Okay, we are extremely better off because we have this, you know, a great internet infrastructure. But for many investors, they've lost a lot of money. That's what we call an externality in economics. Okay, there's bigger value. You know, the person who pays for it doesn't capture the whole value. You're going to get too little investment in those kind of things. Okay, this is when I come to defense. Okay, I think the government has a huge role to play in creating innovation because the defense is going to pay. Or NASA in the US, okay, they're going to pay enormous amounts of money, not because they want to make money from this, but because they want to, you know, kill people. I wasn't. No, but because or you know, for other political reasons. Okay. However, we as a society will benefit from these innovations. Okay, and these will create actually commercial companies that are now viable. So I think to get any serious innovation going, you need an important, you need government intervention. You typically, and the type of government intervention where the government, invests as an investor in companies, maybe that works, but that's the most effective way to get these markets going. The most effective government policy is actually having the government policy as a buyer, okay, of new inventions. Okay, so that's, I think, the defense definitely is going to be an important factor going forward.
I can talk about sex. I had up there the 14 failed business models that iRobot had. None involving sex there. But I started a company with Colin Engel and Helen Grainer, who were undergraduate students in 1990, and we were searching for business models all the time. And after our planetary exploration business model had failed, although the rover that went to Mars was a direct descendant of stuff we'd built from NASA. We were looking around and we noticed that lots of technologies from photography to VHS video had been driven by the sex industry. So we spent some time thinking about it, the three of us, and we actually came up with 3 different businesses in the sex industry. And then Helen said, "Well, what if we're successful? What am I going to tell my parents about where the money came from?" And so we stopped. We didn't go forward.
That's a great question. We have a question from the gentleman in the front. Who are you? Where are you from?
Per Strömberg from the Robots podcast. I would like to ask you what you think about the new forms of financing we see, like Kickstarter, where there's like the first 1,000 customers is actually the one that finance your product. We've seen huge success there, where companies receiving nearly $1 million already.
Yeah, not many are getting $1 million. $1 million is high for Kickstarter, and it's low for a robotics startup, unfortunately. So I don't quite see that model at the moment helping. But it helps people maybe build, for small products. It helps them. Although there are also some horror stories starting to come around about Kickstarter too. So it's a mixed bag.
But if we don't focus too much on the sort of early social funding, my microphone on? Oh, could you? All right. We have so lovely technical issues. The building is, after all, called Lokomotiv. Anyway, but I have a loud voice, I don't care. If we don't focus so much on the particular brands, the model social peer-to-peer funding, what about it? Does it carry potential, future thinking, long view?
So I think it's a very interesting model that's going to grow. I share some of the skepticism here, because first of all, it's hard to raise larger amounts of money. Okay? Even if you can find the odd exceptions, it's hard to find larger amounts of money. The other thing that I think is important and may make this model backfire is that you don't necessarily fund the best companies this way. Okay? There's a very interesting study by a finance professor, Enriqueta Ravina, who is at Columbia, where she looked at one of these sites and saw, okay, which kind of companies got funded. She took the photos of the people, okay, through these sort of programs where you can basically measure how attractive someone is. Okay, if you have a very symmetric face, you don't have like a forehead that goes like that, like I have. Okay, then you're considered to be more beautiful. More beautiful people got more funding. Okay. Now, in a few years, I'm not so sure there's a big correlation with success. Okay, so I think we may see a little bit of these things backfire.
Yeah, actually, I want to take that model. It's interesting, but it does have a problem that you have a lot of investors who feel they need some input. And this gets back to when you talk about angels. One of the problems with angel investments, at least in my experience, is they all think they're experts. And if they're in one of these gangs of angels, suddenly you have 50 investors who are all demanding attention from the entrepreneur. And you're trying to build a product, and they want to come in with meetings and just talk about things. And you've got 50 of them. And they remove value rather than add value. So you need to keep a little distance from even your VCs, even your really good VCs. You don't want to get them too involved, because they will offer too much advice and not, and this gets back to a point that Magnus was making earlier before him, and tell you what can't be done, and often the innovation is from people who don't know what can't be done, so they go and do it. And so too many investors can make it worse.
Thank you. We have a question on the side. Shall I throw you the roving mic, or ride with it, or have a loud voice? I'll run with it. There you go.
So, and we can't see you at all.
Oh,
Yes.
that's right.
Who are you and where are you from? And
I'm not very beautiful, so I won't get much. I'm going to involve the customer, the end user here. So the speed of acceptance of robotics for the elderly, the aging population. And of course connecting that to actually getting capital to fund these companies. So the speed of acceptance of robotics for women, for plus 60, that's a huge challenge. And everyone that's sitting here has probably at least one computer and etc. We're used to working with Skype, etc. So I'm Patrick Bjorn, by the way. I work with industrial design, so that might be a reason for my perspective.
your question is?
How do we speed up acceptance among end users? Because you all have spoken about the aging population.
Thank you.
Well, first it's important to remember that a lot of aging population...
Sorry, Anders. Here's the hand mic.
Have this one stopped? It's important to remember, of course, that we are part of aging population. In a few years, sadly, a lot of us are going to be also among those older people. So generally, I found when trying to explain computers and gadgets to elderly relatives that as long as we don't have a good reason to use them, they don't get it. But as soon as we realize that it could be useful, suddenly we get it very quickly. So I think it's more about, well, what is the application? Find a robotics application that people actually find a practical use for, and we're going to pick it up. And then, of course, we're going to tell your other friends in the same age group, and you're going to get a lot of spread.
Yeah, can I give an example? I'm very close to what you call elderly there, by the way. And I don't know whether I'll be able to handle this robot. But I think it's important for the robot designers to make the systems so they're very close to what people already know how to use. So a great example with the PCs was the spreadsheet was modeled after what you do on paper, and so it wasn't a big jump. Let me give you another example. The robots that we sent through my company to Iraq and Afghanistan, we got word back that and this was a technical description, that the engineer designed menu interface with force reflecting joystick controllers, the description that came back from the field was that the interface sucked. And one of our engineers, MIT trained engineers, said, "Oh, well, we need smarter users then." That wasn't the right solution. The right solution was to take a hardened Game Boy controller and have a new interface which was based on the standard stuff that any gamer already knew, and with zero training, as distinct from a lot of training before, 5 minutes playing, the average user in the US military, 19-year-old kids, were getting 85% of the functionality of the robot. They never got that high with training with the old interface. So it's matching the interaction, and the interaction model, I think, is important to get that acceptance and that ease of use, along with it actually doing something that people want. If it doesn't do something that people want or find useful, it isn't.
This meme, if you will, aging population, demographics, nobody wants to work in hospital, but ta-da, we will have robots. There's something wrong in that assumption, I can only feel. There's a grave error in that prediction. It sounds cute, it sounds so formalized. It's like, well, libraries are going bad, so we will invent something called the internet, if you will. You define, it's like you have robotics, it's a product looking for a need. How willing would you be to make $1 million bet or investment as it is that aging population will be an area of early adoption in these kinds of technologies? With all due respect to the prototypes we see floating around today.
Well, recently in Denmark, there was a change in one of the counties, I guess they call it, where if you have a government person come to your house to help with the house cleaning for the elderly, you now have to own a robot vacuum cleaner for them to use, because they have to be more productive
and not actually push the vacuum cleaner around. They come and switch on the robot vacuum cleaner. So we're starting to see economics.
Well, Danes are a bit strange, but okay,
No,
in Denmark it's happening.
But the point is, it's a pull on productivity. So whatever, and it may be spreadsheets, it may be something else, whatever gives more productivity is going to eventually get into the equation. Because there's just not enough bodies to go around to do the same things for the elderly. So my own mother in Australia, who's almost bedridden in elderly care, says that it's very strange, but now there's, you'll excuse, as I say her words, she said, now there's an African man who comes and washes me. Because in Australia there were not enough people who wanted to do that sort of work, so African immigrants are the people who do that. And there were no African immigrants 10 years ago in Australia. So once you've used up all the African immigrants, then who's going to wash them when they're old?
Right, right, I see. Well, it's sensitive. We might get back to it. But what I lack sometimes when it comes to robotics is silliness. It's always so serious. It's like, oh, like good, beautiful stuff and aging and carrying stuff. Where's the silliness? You touched upon it with the sex, but like the thing, when the mobile phone was new, you didn't go, oh, the mobile revolution. You called up a friend saying, dude, I'm in a car. And then you hung up because it was so expensive. You know, where is the silliness in robots?
The problem is we can't predict silliness because then it wouldn't be funny. Demographics is wonderful if you're doing future studies because you can rely on people getting 1 year older every year. At least until my friends in the life extension business actually get their act together and cure aging. But even then, it's not going to be a rapid transition. However, all the fun applications we're seeing today, they're completely impossible to predict because we didn't have a culture or ideas. If somebody had described the internet of today to me back in 1991 when I first got onto the internet, I could have immediately said, yeah, that Twitter thing, yeah, I could probably implement something like that. YouTube, no, it's not enough bandwidth, so I can't imagine that ever taking off. I wouldn't have been able to understand the social web, because that is a practice with the murder. And cat videos. Why cats? Why video? That's not obvious until you do it. And when you do it, it's obvious, and somebody's making a lot of money, I hope. But before that, we can't figure it out.
Is that sorry? Yes, of course. You're the speaker.
There is some fun in robotics. I want to show you.
Dazzle me.
There's a, you know, it's hard to understand other cultures. So one culture that I don't understand at all is Texas. So in Texas, there has been a sport that you drink a lot of beer, and then you go out on the side of a busy road with your frog, and you bet on whose frog is going to get to the other side without it being squished.
Yeah.
Well, now, Roombas, which have a serial interface, and you can put a controller on it, there's Roomba frogging in Texas, where people go out with their Roombas, with their remote controls for them, and bet on whose Roomba is going to get to the other side of the freeway before being squished.
Wow. That would be Dallas, Fort Worth, where people are a bit more affluent, I suppose. Do we, Per Strömberg, do we have a problem also in financing, because silliness doesn't get financed? Cats that look like Hitler.com didn't find early investors.
Definitely, okay. And so part of these professional investors, we call them riskkapital in Sweden, which means, you know, risk capital, okay? Maybe they like to take risks, but they hate uncertainty, okay? So one of the things we see is that the venture capital funds are only going to get into the internet, for example, when you actually, someone has already shown that you can make money in the internet, okay? They won't be the critical guys investing in this first technology that's going to change the world, but maybe they invest in the company that's founded after the company that changed the world, okay? So I think that that's where we need people to actually, you know, invest their own money, you know, in their vision. And we probably, as I said, we need the government here. And I think that having the government, you know, investing in stuff, investing in infrastructure, and then that infrastructure enables people to start thinking about, you know, Facebook and so on. I think is an important piece.
Right.
Of course, investing your own money also generally requires it to be fairly cheap, low thresholds to entry. One reason why cat movies have worked so well on the internet was their threshold of entry to the internet was so low.
Robotics might have a problem that most robots are fairly expensive toys. Roombas are apparently cheap enough, but ideally we should be looking for getting even cheaper ones that you can actually try out. Then I think we're going to get the fun stuff that people will pay a lot to.
Thank you. We have a question from the audience. Who are you and where are you from? The second one.
I'm Per Strömberg, and in my spare time I work in a bank, but that has nothing to do with why I'm here. I really liked the matrix you had, Rodney, and the table, the CEO perspective and the academic perspective, and that there are gaps there. There might be some conflicts in motivation. What would be your suggestion if you have the, let's say, the CEO perspective and you want to achieve something, and you're not being able to communicate to the academics who have the knowledge, but now the different drives? What would be your advice to the CEO type in that situation? How to communicate and come across and get something done, actually?
Yeah, that's a good question. So
It works.
Oh, okay.
It works. Sorry.
You know, I've been at my new company, even though I've had other companies. My new company, I have a professional CEO, and he gets very frustrated with me and still thinks of, you know, I'm the academic. The academics that I used to work with think I'm completely tainted as being a company guy. So it's a big spectrum. I think the CEO has to help the academic understand what the gap is between their language and the language of the customers and the language of the engineers who are going to implement the ideas, and help them see how they need to they can still have the idea, but they need to be able to translate it into ways that show the customer, this is my customer, show him that there might be value, and then show the engineer that there are a set of steps which can be taken to get to this dream they have, this vision. And it's getting the academic to understand that there's a whole bunch of steps that have to be articulated, which they wouldn't normally articulate with their PhD student. Because if a professor says, we're going to use support vector machines to do learning on a large data set to the grad student doesn't have a clue what it is. They run off and find out because they're motivated not to appear stupid to the professor. But the engineer's saying, forget it. I don't understand that. Don't try to make me do that. So it's translation is what you have to learn to do.
I mean, this is an important problem, not just for startups, but for any engineering type company. And actually, I don't know, many of those of you in the industry know, one of the buzzwords right now is lean manufacturing, okay? So lean manufacturing may sound like something, okay, we're just going to cut costs here to be cheaper. But a big part of what lean manufacturing is about is having a culture in these engineering-based companies where everyone thinks about the value in the end, okay? What's this going to mean to the customer? Are we actually going to, is someone's going to be willing to pay more for this thing that I'm doing, okay? So Toyota, who's like the big, founding father of lean manufacturing, what they did so revolutionized is basically everyone from the engineers who design, the very little, thing that goes into the car, the people who assemble it, people who spray paint it and so on, are kind of indoctrinated, if you will, with this thing that what I'm doing, everything I'm doing is about increasing the value to the customer in the end. And getting that kind of culture in an organization can be very powerful, but it's obviously a challenge.
And we forget that Moore's law isn't actually a law, it's a management objective, in essence. We had a question over here, an elderly gentleman and then another gentleman behind him. So let me rove over with a mic to you. Who are you, where are you from, and your question?
Hey, my name is Carl Oman. I have a company called AI System, Artificial Intelligence System, and I have a question about intelligent cars. I know iRobot has received some $35 million for developing a military ground vehicle. And what spin-offs can there be to intelligent cars? And one incentive, for example, is automotive safety. There's so many millions of people dying and being hurt. And how far away in time is the introduction of intelligent cars? That's my question.
Thank you, Carl.
Is that my? Yeah. So I actually think I often use cars as an example of systems that are becoming robots, and it's actually a place where trickle down works. So the Mercedes and some companies like that are putting systems in high-end cars, and a great example was with the ABS brakes. Originally they were in the very high-end cars. They're much better at braking than I can ever be on ice. And then they went from Mercedes to Volvos, and now they're in Hyundais. They've trickled down to the lower and lower value. Likewise, we see the high-end car companies, some of them working with some of the academics who are funded by the US Defense Department, and then some of the EU programs here in Europe. So the higher-end car companies, it seems to me, in my travels around, are working with academics and taking the prototype ideas and putting them in, and then they're coming down to the lower and lower value cars. I think that's working very well. And actually, the cars are another great example. Imagine if I was starting a company in the US and I went went out to the VCs and I went out to the government and said, I'm going to design a new transportation system for the country, and it's only going to kill 35,000 people per year. There's no way I could get any funding or any trials. But when we have automobiles that kill 35,000 people a year in the US, and I assume it's a similar number in Europe, so we should be doing something about it. But I actually see that is happening, and the Japanese car companies are really driven by the safety record, as are the high-end European car manufacturers trickling down. So I think it's just happening.
I also think it's an interesting case where you might start thinking of the car as a platform. What's the apps you can run on a robotic car? It seems to be an enormous market of a lot of kind of robotics applications once you have the automated car. And of course, like the cell phone market demonstrates, you can also sell stuff that's attached to technology, parapraxis, to use Ingmar Nordin's term, the technologies that adhere to each other. So I think as soon as you get a robotic car, you're also going to get the counterpart to cat videos. Who knows what that's going to be?
Well, talking about robotic cars, if you allow me to ask a rather stupid question, but what isn't a robot? Because we've seen everything here from sort of wannabe humanoid shapes to things that look like, a Segway with a screen on it. What does something have to do to qualify as a robot? In your pragmatic and philosophical and financial.
My definition of a robot is it's a physical device which senses the world, does some computation, and then reaches outside itself and interacts and changes the world in some way. And I say outside itself because I don't want a dishwasher to be a robot, a dishwashing machine. It's going to reach out into the environment and do something there. So the video screens on top of a Segway are getting in your way and changing the world by moving around.
Right. And I don't want to sort of fall into a pit of philosophical mire that I do not master, but you used word like itself and reach. I mean, surely here there must be some grey areas, I can only assume.
There is a lot of grey areas. One thing I didn't have the time to get into that, I think a lot of robots are not going to have a clear inside or outside, because we're going to be using a lot of sensors in the environment. Actually, a lot of them already do that, but kind of on the slide. We're not carried around in a little moving box. But since we're all carrying around sensors and surveillance equipment, why not use all our phones, for example, as inputs to a robot? And then, of course, the brain is actually residing somewhere in a cloud computing center somewhere, and then the actuators might indeed be in a little box. But where is the inside and outside in that case?
Right.
I think it makes sense to think of it as a system, but sometimes it's going to be very fuzzy. We're going to get cloud robots. So.
Right. We had another question from a young gentleman in the back. Yes, and I shall make my way over to you, unless you have a strong voice. But you have a nice beard anyway. What's your name? Where are you from? And what's your question?
Okay, I'm Henning Victorin. I'm a student at the school. And I wonder, when do you think robotics would be a subject in school in the early school, like for little kids?
How early school did you say?
Like 10-year-old kids.
Oh, Well, I think again, the risk of using Denmark as an example again, I didn't know was.
The Xeno folks and all that, but it's okay. You can use it. It's probably all the same. Yeah.
In some sense, robots is getting into a lot of school through Lego with the brick controller, but it's, at least in the US, I can tell you what's happening at the undergraduate level. Robotics courses are becoming the first course in engineering because it gets people to work in teams and work across mechanical, electrical, and computational. And so it's seen as a real vehicle for getting people, to stop people going into silos early on in their very first year as an undergraduate. And so at MIT, the very first course, taught by the electrical engineering department, but taken by 60% of all the undergraduates, now that means 600 students a year, is a robotics course where every week they have to do work on mobile robots, 600 students at once. We've got lots of mobile robots. At Worcester Polytech nearby, there's an undergraduate major now. So we're seeing robotics really becoming the core of, robotics and app programming on cell phones have now become the two ways of making engineering more real in US undergraduate colleges.
And of course, if you need to teach kids in school about how to use a robot, then the robots are obviously too hard to use. So ideally, of course, kids pick it up because they want to play games and play with them. That's the kind of technology that's actually gets widely used. The fact that we might need computer courses is kind of testament that they haven't built a really good user interface yet.
When will your first best friend in school be a robot?
We actually did a survey. We had a conference on artificial intelligence where people were making estimates. And of course, one shouldn't trust the experts, especially experts going to AI conferences because they might be a bit optimistic. But the kind of median estimate was 50% chance by 2060 that got human-level AI, which kind of scared us quite a lot. 60, which was unexpected pessimistic, but some of them think of it much earlier. Our research actually about the risks of human level and beyond AI tell us that we want it as late as possible, which makes it rather weird for being futurist.
We had another gentleman sitting next to Henning with a beard, and then we have time for one more question up there. So who are you? Where are you from?
Fredrik Heinz, Linköping University. So I'm an AI researcher, so I guess I'm one of those you shouldn't trust. But my question is about artificial intelligence, and should we make, or how important is it to make the robots smarter, more intelligent, and what are the downsides? Should we not make them smarter, because then we get into the risk that they might be less safe, or people feel that, oh, they will take control of our world and so on. So my question is, how important is artificial intelligence for robots?
They will start fighting Will Smith. Sorry.
I was worried about some of that slide that you had, and I think people are falling prey to Hollywood. The robots are going to take over. If you go back to the 60s, the movies were about the computers going to take over, especially if they were networked. There was the Forbin project was about what would happen if you networked an American computer with a Russian computer. They would take over the world. And they had punch cards. They were doing it with punch cards in 1964. And the Hollywood movies is the robots are going to take over the world. And I don't really base my predictions about the world on Hollywood, because Hollywood also says there are aliens everywhere firing machine guns for some reason. And there are ghosts everywhere, and that doesn't come into my life. So I don't think these robots taking over the world are going to come into our life. We could build dangerous trains if we wanted to. We don't build dangerous trains. We have regulations. We have safety standards. You're not going to get a robot that wants to take over the world without first getting a really ornery robot that's annoying sometime before that, and you'll change the way it gets developed. I think this is to me like, it's 1793, and we're in Paris, and there's a hot air balloon floating over with a person on it, and everyone's saying, how are we going to deal with noise control when these things land? You know, they didn't know what the right thing to worry about was, which is now a big thing. We can't possibly know what the downsides and what the difficulty is going to be. It's all, and to, you know, to get back to that earlier question, it's all mental masturbation. I'm sorry.
Professor Brooks, I see you had this question before, but surely there must be some interesting dilemmas. We were talking about, you know, sex dolls before. If you had a sex robot, would you be allowed to do it in the shape of a child? I mean, it's just, you know, it's just a machine. Surely, these poses, and that's not necessarily based on Hollywood, but it's like the realms of our creativity and what it can create.
But actually, that's a good example, because that's something that someone could do today.
Yeah.
We're already there.
And probably is doing, unfortunately.
Yeah. But it's there. Whereas the robots taking over the world, that's so far off. There's so many unknowns about how it would happen that we can't make.
But it's the same question. It's like progress versus societal fences, I guess.
Yeah, but you can do it with drawings too. I mean, so
right.
One of the weird things is that the history of AI is filled with prediction that within 10 or 20 years we're going to have human-level AI. And nobody was taken seriously in security consideration with that back in the 50s and 60s. The time people started thinking about the security implications and safety implications seriously was in the 90s, where people already were a bit disillusioned. My argument for why we should be concerned about really smart machines is that intelligence is about getting what you want, whatever your motivation is. And we're very bad at coming up with clever motivations. It doesn't take too much work demonstrated. A lot of fairly obvious and apparently safe motivation have surprisingly dangerous side effects. This is not a problem as long as the robots are fairly down. At that point, there is we have other ethical issues, and in many cases we don't want too smart robots, because if they adapt too much, they become unpredictable and we don't trust them. But in the long run, we shouldn't underestimate the problem of getting too smart systems. It's just that it turned out to be really hard to make smart systems. The scary part, we don't know why it's very hard, and we're not very good at measuring how far away we are from figuring out how to make them smarter. But right now, there's no cause for concern.
I would love to contribute to this discussion, but my batteries are running out.
Batteries are running low. We had one more gentleman. If you could toss the mic, it's difficult for me to start stage diving. And who are you, where you're from, and this shall be the last question of the session. So it better be good.
I'm Zishan from Maryland University. I'm a master's student in embedded systems. My question was more or less like the same as the last question, but I would like to add a few things in it. Like, we were having the industrial age earlier, many years ago, and it was considered to be the ease will come in the life. And when the industry will come up to the top, then we get that environment will get damaged. And what if that robotics will come up to the top and we'll get the damage in the environment. We're already getting the damage in our social life because of the robotics.
Yeah, what's the climate change of robots in essence is all?
Yes.
Yes, okay. Any speculation here? Great question.
Well, one obvious thing would of course be kind of laziness, but also of course that the job market would change quite rapidly and it would be hard for humans to adapt. But I think it's important to remember that the previous crisis caused by previous technology, quite often we find ways around. We have a reading and writing crisis. Socrates was complaining that people were not thinking for themselves because they're reading rather than talking to each other. We kind of got over that. I think we're going to, similarly, now advanced technology realize, oh, the environment is really important. Spend actually a lot of effort and intelligence on maintaining and making the environment better. So similarly, we're certain to run into trouble with robots. It's just that we're also going to be working very hard on fixing it.
So I can't help feeling that we've had three really good complementary perspectives. We've had the kind of broad techno-philosophical overview. We've had a business cultivator to show you how it can be done, and we've had the money man. Yet some people in here will still go home to watch television tonight. It's rather sad. But then they will wake up 6 months from now and say, you know, my job and my life is crap. I got to call one of these people up to get busy starting my company. Thank you for traveling long and far. We have gifts for you based on rather, I have to say, sloppy assumptions. So Professor Brooks, you get a book called Ascent of Sweden, which has a really nice pun in it, in its title, which, you know, and it's, you could not mistake it. There's a Dala horse and a Swedish flag. The Swedish flags are only allowed outside of Sweden, so. And Anders Sandberg, even though you have a Swedish name and are Swedish, we sort of assume you know nothing about Sweden, so you get the same book. But Per Strömberg, we knew you were Swedish, so we assume you know nothing about the world. So you get the rather awkwardly named book, Vad som händer I världen och varför det är viktigt att förstå, which is almost as appalling a title as I would do anything for love, but I won't do that by Meatloaf. So here you go, give them a round of hands, ladies and gentlemen. I can't help to feel that Per Strömberg is so much more engaging and captivating than his PowerPoint. You know, we've got to work on that. We're about to switch rooms. Like I said, this building reveals itself in layers. It's like an onion. In here, one floor down, is an innovation catwalk where you will see where we are at. What's the state of the art? What has been created in or around Robotdalen? And you know what they say, right? R&D should actually stand for rip-off and duplicate. So that might be the embryo fueling your billion-krona fortune and fame. So in about 15 minutes we will begin the show. It's going to be fairly brief, then we have lunch, mingling, ideas, we'll have sex, and all that. So we'll see you downstairs in about 15 minutes. Thank you.